So thank you for the introduction. I'm super happy to be here today with you. So hi, I'm Mateusz. I'm an assistant professor at the Warsaw University of Technology, which is this lovely building just a few steps away from here. Last year I defended my PhD over there. And apart from my scientific work, I've also worked for some cool companies, Apple being the most recent one. But apart from the whole computer science and programming thing, I've also been a professional musician for the last 10 years or so. I play drums. I've been super fortunate to have the opportunity to tour a bunch of different places all over the world with some inspiring artists. So this is Michał Milczarek Trio. We've played, and these are the two tour posters of our tours in China. We've also played in some other countries as well. This is the Polish rapper Grubson that you may know. This is the band The Dumplings, and I am the permanent drummer of this band since 2019. And I also play children's music with Majka Jeżowska, and the weird thing with children is that children grow up, and at some point you end up, at the Woodstock, also known as Poland Rock Festival, with like 100K people in the audience, and things get crazy. So I'm also very happy, very fortunate to have had the opportunity to play music for people on so many occasions. But at some point you're kind of looking for a way to combine the two things that interest you, and this is how we arrive at MIR, which stands for Music Information Retrieval, which is the research domain that I'm mostly focused with. So the primary goal of music information retrieval is processing music in useful ways, and that's pretty obvious, right? But music is also like a pretty complex and complicated signal and data type on itself, and we'll have the occasion to take a deep dive into that as well. Now, one of the most impressive parts of AI is that AI generates stuff, right? And AI can also generate music, and generative music has a bunch of its own terms, but it's also often referred to as also a part of music information retrieval. So we'll just go with that term over here. And in this kind of a form of a feedback loop, music information retrieval also enhances our perception of music, because we learn just so much more about how we consume and how we create music along the way. So before we talk about the information retrieval part, let's talk about music. So is anybody over here a musician? Have you ever played any instruments? Just raise your hand if so. Okay, raise your hand if you've perhaps played in a band or played with some friends or had the occasion to play live. Awesome. And how many of you have never played anything, just came into contact with music only from the listener's perspective? Yeah, also a bunch of people. Okay, cool. So I think that we can agree upon that, music is kind of multi-dimensional, right? Because there are so many ways to describe music. I mean, there's the genre, right? Like rock, pop, jazz, etc., and mixtures of those. There's the mood, right? And there's also like the music's mood. Like, does this music sound angry or does it sound happy? And like the inducted mood. Does it make me happy or does it make me angry? There's instrumentation, so what instruments were used or like what production details were used. There's the timbre, so it is also about the sonic quality of the music. The structure, right? Because like pop songs have a totally different structure than, let's say, symphonic pieces from a couple of hundred years ago. There's also harmony, so we're getting low level. So these are the rules that govern how you create music that sounds good or sounds pleasant or sounds dissonant or like sounds tense. And there's also rhythm, which is how the music is organized in time. So I think we can agree on the fact that it's a pretty deep and complex form of expression and communication. And how the heck do we interact with this thing using, programming and the stuff that we're comfortable with? Well, that's the first question that we'll try to answer today. It turns out that Python has a pretty rich ecosystem of how you can do things. So who knows what this is? Yeah, this is a guitar pedal board, right? So you plug your guitar into this stuff, and like these little devices make your guitar sound different, right? So it goes from like a soft sound, like a distorted sound, or any other effects. And pedalboard just happens to be the name of a open source library by Spotify that you can use for creating audio effects. It emulates many popular musical effects like reverb, like delay, like distortion, etc. It's mostly used for data augmentation for machine learning models, but you can just use it on your own recordings. And it's super simple. The first 2 lines are just plain old imports. Then you open a file. Then on line 10, you create an instance of a board which just takes a list of effects for initialization, and then on line 13 you just run a single line of code to run your audio through the effects board. Another cool library in Python it's called PyWaw. It's like a low-level audio synthesis engine where you can kind of on the DSP, which means digital signal processing, kind of on the DSP level, you can program your own effects and synthesizers and oscillators and all sorts of that stuff. And this is actually used in live performances. So there's this guy named Mateusz. You can watch his presentation from one of the previous EuroPythons, I think, and they, along with his band, he plays like this medieval Baroque Renaissance type of music, and under the hood they are running a laptop running Python with custom wrote software implemented in PyWaw, and they're using it for live effects, for live looping. So they have kind of like a digital version of their show running just alongside what they're playing on live instruments. Kind of if you made your own custom Ableton Live type of software. So I think it's also really cool. There's also a multitude of other important and interesting libraries. There's Audiomentations, which does a similar thing to pedalboard. There's PyDub and Soundfile, which allow you to edit audio, to read in different formats, etc. But there's also APIs. So the 2 most well-known ones are the Spotify API and the Deezer API. Both of these are streaming services which provide music, and you can find a whole lot of features like audio features like mood, danceability, energy, acousticness. You can find information about the musical structure. You can find information about metadata, about the albums, etc., etc. So if you're looking for an idea for your next I don't know, like web app or data visualization project or something like that, why not give these APIs a try? So if you take a look, there's this website called Every Noise at Once, and it's like the scatter plot of all the genres from Spotify are ranked by some weird criterion. I think that on the y-axis, it's like how acoustic and how lively the music is. So on the very top, you've got stuff like Italian tech house, UA tech house, and Swiss house, and dark techno. And if you go all the way to the bottom, you end up somewhere over here with Polish classical piano. So I think this is a pretty neat website. Apart from the APIs, there's also a whole bunch of data sets, and there's ISMIR, which is the most famous MIR conference, and they also maintain this curated list of data sets. So some of them contain audio, some of them contain lyrics or MIDI files or different type of musical data. So also there's plenty of data to choose from, whatever interests you for your next project. And also there's a library called MIR data, which provides very convenient utility and wrapper functions for many of those data sets. So you don't even have to work with them manually. There's also Librosa, which is like the library for audio analysis. You would use this for music processing, for visualization, for feature extraction, because before deep learning and neural networks came, what we would do is similar to the trends from computer vision, where you would like handcraft the features and compute a bunch of spectral features and then just use a little bit of machine learning on top of that. Well, all of those spectral features you can compute with this library. And again, it's very Pythonic. It's very simple. On line 4, we load in the audio file. Why is the audio? Because like audio is just a long vector of amplitudes, and the sample rate. And line 5 allows you actually to perform harmonic percussive separation. So in one of the results, you have the harmonic part of the audio, and the other part is the percussive part, which contains most of the transients, right? And then lines 8 and 9 show you how to compute a spectrogram, which is one of the most common representations of audio. This is like a heat map of frequencies over time, right? And this brings us to different representations of audio and music, because audio is just one part. This is the thing that we can actually listen to. But there's also like another separate world of how music can be represented, and this is called symbolic formats. So audio we can listen to, symbolic we can't listen to. This is just like a digital version of the sheet music of the music, right? And MIDI is the most common format that's used. It's very relevant in music production. It's also very relevant for music information retrieval. But this is the key distinction. This is going to be very important down the road. And also, there's a ton of Python tools that you can just experiment with to play with MIDI. There's Pretty MIDI, which is like the Python library for MIDI manipulation. There's MusePy. There's Partitura, which also kind of allows you to go deeper into like the performance part, so like the dynamics, etc. And just a bunch of other libraries. But okay, now we know how to kind of get our heads around working with music using Python, but what can we actually learn from the music? So in most of the cases, we will have our music, then we feed it through some kind of model, and we expect some sort of prediction, right? So I think that like the mother of all music information retrieval tasks is music tagging. For instance, we want to classify the genre of the music, but in real life, there's usually more of these tags, and we would like to get more than one at once. So the problem becomes pretty complex pretty quickly, and it ends up, you know, in this kind of a multi-label setting kind of thing. The good news is there's amazing resources for how to handle this. I can't recommend this one enough. This is from 2 years ago from Ismir. This is a tutorial book which is like a great introduction to music tagging and music classification, but also to deep learning and neural networks in general. If you've had a hard time finding like a good place, like a good spot to you know start learning about deep learning or neural networks, I think this is a nice place to start. And also there's open source implementations of most of the state-of-the-art tagging models, so you can just clone this repo, you can retrain the model, or you can use ones that have pre-trained weights, and you're off to doing your own classification experiments, which is I think very interesting. Okay, Another task might be automatic mixing, which is you start from the stems, so the tracks that contain like particular instruments. You once again feed it into a model, and you expect the model to output the final track with the right balance of volumes, with effects, with processing. So this is a pretty non-trivial task, because like this is something where you would employ like an actual mixing engineer, and it's a very creative process, and it's also difficult. So this is really not a trivial task. But again, there's this came out like a month ago or something like that. This is also was published on ISMIR. There's already a tutorial and a very nice book that outlines the data sets and outlines the approaches that you can use to start experimenting with automatic mixing. So also I think this is gonna be, this may kind of blow up and be very, very practical and applicable in the near future. And then there's the other way around. So you start off again with some music, you feed it into a model, and what do you expect? You expect the separated tracks. So this is also difficult because it's kind of like unmixing a bucket of paint, right? But it turns out we also know how to do that as well. So this is, I think this is still the state-of-the-art model. This is called DMux. It was developed by Facebook, and it's like this massive UNet architecture. We don't have to go into the details. It's just this, you know, intimidating looking model. But there's also another model called Splitter. It was made by Deezer. There's a open source library. You can just use it, and this is already being productionized. So maybe I can show you how this sounds. So it's actually already deployed in music production software.
Stems auto-populate across the top of the application. Let's take a listen.
Way far down, I sink ever deeper now as I go low. Could you come around? I go way far down.
And the bass, it's much softer and harder to hear. But this is something that's already being deployed and used. And the separation into 4 stems, being vocals, bass, drums, and other, this is mostly because of the data sets that we have at hand. This is not like the only scenario that's generally possible. Oh yeah, and this is the plugin that allows you, like in real music production software, to use this. There's also other libraries and other approaches, maybe more traditional ones, like pre-deep learning ones, based mostly off of matrix factorization. But here again, there's very convenient Python tools that you can simply download. You can download the pre-trained models. This is called Nozzle. This is by the friendly people at the Northwestern University. And this already comes with like a Gradio interface that you can just play with. You can upload your own tracks, and it works reasonably well. And there's much interest into this side of research. So 2 interesting papers that also came out like a month ago, so this is super fresh, is how do you separate sources in like modern music, which tends to be compressed really quite a lot, and when you've got, you know, like very compressed dynamics, the task becomes more difficult. And also some post-processing. So the last one here, music separation enhancement with generative modeling. This is an interesting thing. They created this model. It's called MSG, Make It Sound Good, and it just post-processes the outputs of DMux and Splitter and other models to make them sound even better. There's also, of course, the topic of music recommendations and music recommendations. This is like a complex topic with massive business and cultural impact on its own, and it encompasses many of the tasks that we've already talked about, like tagging, retrieval, ranking. There's a lot of engineering. There's A/B testing. This is like a massive enterprise on its own. And here again, Python comes to the rescue. There's already some libraries that you can just use and experiment with. I just wanted to give like a super quick notice about music representations, because we spoke about symbolic and audio, but those are not the only ones. Actually, you can ask a neural network to produce representations of music. These are just vectors of numbers, but they encompass like the information from the music in very meaningful ways. So these models like OpenL3 are called embedding models. So these models just take in your data and they compute like a numerical representation of it. That turns out to kind of compress much of the information that's useful. And of course, there's a plethora of other tasks. We could spend, a lot of time just talking about learning from music. But I think that the part that kind of often gets people excited is generating music. And this is the last part that we're going to talk about. So again, we've got two representations. We've got audio and symbolic music. And here we also have two names for what we're working with. If we are generating audio, we mostly tend to talk about neural audio synthesis. And when we generate MIDI or other symbolic formats, we talk about symbolic music generation. So this is like AI-assisted composition. Yeah, and that's basically what I said. So the first case, we generate audio. The second case, we generate something that we can't listen back to. But for instance, you can run this through a synthesizer and you get actual audio back. So this idea of neural audio synthesis, it's nothing new, but one of the impressive implementations was around 2016 when Aaron van den Noord and a bunch of his friends proposed PixelRNN, and shortly thereafter also WaveNet. So these were neural networks, pretty complicated ones. They use this idea of like a dilated convolution to kind of get a bigger receptive field, and this was used for modeling audio and for modeling speech and for modeling music as well. Another interesting idea comes from 2020. It's called DDSP, which is differentiable digital signal processing. And it's basically the idea of making kind of like a synthesizer that you can differentiate and you can do backpropagation on. So this thing is by Google Magenta. It's a autoencoder that kind of learns to encode synthesis parameters like pitch, amplitude, noise, and harmonics. And basically what you can do with this device is try to synthesize different instruments. And I've also got a demo for this thing. It's this guy.
Tone transfer is a technology developed by the Magenta team in Google AI that allows you to deconstruct sound into Play-Doh and enables you to mold it into something else. So if you took the sound of birds chirping, or if the sound of you singing, it can remold that input into the sound of the violin. We do this by training a machine learning model to distill what makes an instrument sound like that particular instrument.
Whatever would that sound like? That's beautiful.
I think that sounds pretty good, the way it captures like the airiness of the flute. I think that's good stuff. Alrighty, and this is also deployed as a VST plugin. So many of the research developments by Google Magenta are deployed as VST plugins. You can just import this into like Ableton or whatever you're using and play around with this. So I think this is also very, very worthwhile. Then, of course, there's OpenAI. So whatever AI task you've got like a massive OpenAI model that just does that in an amazing way. So also in 2020, they proposed this model that's called Jukebox. And this is also something that generates raw audio. And you give it the genre, the artist, and the lyrics, and it just generates a song. So this is a Elvis Presley song that the network hallucinated.
From dusty tiny almost scarf, with the lip hitch tells the heart. When my toes slips, when my hair sits with pine. And at last, when he woke up with a mind, dusty tiny when you help.
I think that's pretty amazing. So yeah, we can do stuff like that as well. And if you want to train your own jukebox, what it takes is around a week on around 8 GPUs. So I mean, yeah, that's probably, you know, quite a lot, but this is also something that's not like totally not obtainable. This is a setup that you can just do in like a cloud environment and like train your own jukebox. And this is precisely what some people are doing. So has anybody here heard about the Banddatabot? Oh yeah, one person. Yeah, they are. So it's this like programmer/musician duo. And I think that like their slogan is something like eliminating the humans from music or something like that. And they are known for creating models that just generate raw audio into infinity. So this is Relentless Doppelganger. This is like a stream of technical death metal that has been playing for over 3 years now, non-stop. And we can listen to a short part of it. This is also hallucinated by a neural network. And this is basically similar to a jukebox model trained on technical death metal. Now, I know that not everybody likes technical death metal, so please bear with me, but this is, and we may also just happen to, you know, arrive at a point where it's generating nonsense, but let's give it a try. No, okay, that does actually sound like technical death metal. Nah, not really. Not really, but the fun part is this has been playing since 4th September 2019, like 24/7 death metal, and they've got a bunch of these radios. So you've got Diffusion Radio, you've got No Soul, which is a 24/7 stream of AI generated funk. You've got an infinite bass solo and stuff like that. Another thing that these guys did is this song called Nuns in a Mosh Pit. This was submitted to the AI song contest last year, and it's like this absolutely outrageous thing that sounds like a cross between Aphex Twin, Behemoth, and Jeffrey Hinton. I mean, it's just absolutely outrageous. Highly recommend it. You can listen to it on YouTube. And this is what the authors say about how they created it. We generated nuns singing Hail Satan, death trees, breakbeats, Guitar Pro riffs, and more using sample RNN, jukebox, catch a waveform, qubit neural synthesis, conceptual synthesis, data GP, and raw audio diffusion. Then assemble the pieces together in Ableton. So, Nuns in the Mosh Pit on YouTube. Check that out, definitely. Now, here's our old friend, the spectrogram, because a couple of times we spoke about diffusion, and stable diffusion has been gaining a lot of attention. You know, like DALL-E is like a diffusion model, but spectrograms are images, and they're a special type of image, because if you rotate it, it means something totally different. And if you shift it or stretch it, it also so you can't use spectrograms without right? No, you can. This is also from like a couple of weeks ago, refusion, stable diffusion on spectrograms. The most interesting part is that this actually works. It does generate raw audio based on a text input, like on a prompt. Some of the prompts really don't sound good, but some of them sound amazing. I've tried Eminem Angry Rap, and it generates something that like sounds, off of a Eminem CD. The vocals don't, but like even the timbre of the voice, it does. Very interesting thing as well. And there's also the last part, symbolic music generation, which is not about generating raw audio, but it's about like the autonomous composition part. And this is a wonderful paper from 2016 where they used recurrent neural networks to generate music, and this was based off of. This is a similar idea. You may know this famous post by Andrei Karpathy, where he wrote a lot about using like a character level recurrent neural network, which was able to generate Shakespeare, C source code, and other stuff like that. So it turns out if you've got just the right data, which happens to be in something that's called the ABC format, which is purely textual, you can just use like a simple model like that. And the authors also present a very nice musical analysis of what this produces. So the data set was like traditional Irish and Celtic music kind of a thing. And they found that the samples generated had the typical structure, they had repetition and variation, they had the correct harmony, they also checked the data set for originality, and they found that the network was making no glaring mistakes. So I think that we can go a long way with a relatively simple model. Of course, there's also the stuff from Google Magenta that we spoke about. So there's more and more complicated models. You can start off from like a simple recurrent neural network and, go just all the way up to transformers. And the guys at Magenta are doing exactly that. You can listen to how the more powerful networks keep longer context than the smaller ones. There's also quite some interest in using GANs, which is generative adversarial networks. The famous setting where you train like two networks, and one of them generates stuff, and the other one kind of distinguishes whether this stuff is generated or is it genuine, is it real. So if you use a bunch of these generators instead of one, you can actually come up with a system that generates multi-track MIDI. So you're generating a bunch of instruments at the same time. And the upside is that you can then freely edit this, because this is just MIDI. You can use any synthesizer you want. More new tools are also being developed, because if we are going towards this scenario where AI is kind of helping us to compose or create music in some ways, we also need new ways to interact with it. So this is also very fresh, couple of weeks ago from last year's ISMIR. There are many ideas of using interfaces that kind of allow you to easily switch the predictions from the model, like maybe I don't like this sample, so I'll take this one, or like to cluster the different proposals from the model. So if you don't like one of them, you already know that you don't like maybe a whole cluster of them. And this brings us back to the engineering part, because as the models become more powerful, we need more powerful tools and interfaces to work with those models. So one thing that I want to just say two sentences about the cultural impact. So this is, of course, sometimes frightening, sometimes very enlightening and very interesting, but MIR also seems to have this big cultural impact because, we are rediscovering how we are interacting with music due to recommender systems, but also there's lots of research and lots of interest going beyond like Western music. So going maybe into Indian music and Asian music. So I think there's beautiful knowledge to be also obtained there. So in summary, I hope that I was able to convince you that MIR enables new experiences for both the listeners and creators. I think we can say that autonomous music AI is still kind of immature, but it's getting there. It already enhances human creativity in novel ways. And I think that also I was able to convince you that Python indeed already has a rich ecosystem for interacting with music, and I encourage you to explore it on your own. So you can find me anywhere on the internet under this handle, Modrzejewski. It was great talking to you today, and I'll be super happy to answer any questions. And this is a QR code for a repo where I've got most of the links that I was showing during the talk. So let's open it up for questions, I think.
I see that we have some questions here. Okay. Okay. Is it working? Okay. So yeah. I have a question. Because you have shown us a couple of tools, a few tools that are able to imitate music creation process. In some ways, they are able to stall a part of someone effort. Because as I see, something called Splitter.
Yeah.
It was able to split music into parts, like a voice, like a guitar, like the drums. As I know, a few weeks ago, Microsoft presented something what can learn your voice. Depends on your some recordings. Yeah. So. The last topic you have mentioned a cultural effect. So what could be an effect at the end if we think about the human effort that could be stolen in seconds or minutes? Because to become a great singer or someone, it's weeks, months, years, sometimes. And with these type of tools, AI generation tools, and some libraries, AI models, we will be able to stall someone's voice in a couple of hours. So in this case, it won't be a destructive for people who want to become professional musicians, because if your years of your efforts could be stolen in a weeks, it's not worth of it. In this case, you can, because we think about intellectual property. I can't just get your recordings and play it in somewhere in my games or somewhere. But if I will play the same music as you, it will be legal, yeah, because it's just an inspiration. So if we think about AI, is it still an inspiration or just theft?
Yeah. I love that question. I mean, this opens up a huge floor for discussion. So I'll try to answer like parts of it. So like the legal part of it, that's interesting because it seems that this is a hot topic for discussion in many research areas, like generating images. You can generate the image like in the style of any painter, right? So I think that on the legal side, like the road is being paved as we walk on it. I mean, there's still like no standard procedures of what to do in terms of copyright law around here. So I also think that this is going to be a bigger and bigger topic. But about the human talent part of it, well, chess engines have been playing chess much better than humans for a totally long time by now, and we still enjoy watching, Magnus Carlsen or Hikaru Nakamura play chess, right? Because humans like to see other humans do difficult stuff. That's basically kind of embedded in our nature. So I don't think that this is like a immediate threat to talented musicians. Also, I think that the development of music has always been in like a tight feedback loop with the development of technology. Whether you think about it, in terms of like the invention of the grand piano, or the invention of like a sampling machine, or the invention of like a DJ's turntable, or like the invention of the saxophone, or like a synthesizer, right? I mean, electronic music and hip hop, etc., like those genres were born out of these new electronic tools, right? So I think that we're still like in the very beginning of how we can use this in creative ways. And like my personal hope is that we'll find new and interesting ways to co-create music with AI. I mean, this is the part of, using a neural network like an instrument. I mean, that sounds kind of cool to me. So I don't know if that answers your question. I mean, there's totally a big floor for discussion over here. So, yeah.
All right. So when do we meet on a concert in the metaverse with AI music? But on if you don't mind, on more serious note, how about unsupervised learning and reinforcement learning? For example, like robots playing guitars. Do you know something about that?
I'm not really like super into robotics or reinforcement learning. I would definitely not call myself an expert on reinforcement learning. I think that the main trend right now seems to still be around deep neural networks of different varieties. So I don't know, but perhaps like if you had a good enough like reward function and like a setting where you were actually steering like a robot to kind of create like do like movements and explore the instrument in some, I don't know, like constrained space, maybe you could also use other approaches, but I don't know too much about. I mean, there's surely somebody doing that right now, right?
But right,
yeah,
right. Kind of curious question, because I think that music is closely correlated with maths. So since machines do math work better than humans, because that's why we created machines and computers to do basically a math work for us, do you think we have long time before this AI in the music world will surpass or will be even match for the most classical composers like Ludwig van Beethoven, or even surpass them in a long time? Or in the long run, it will surpass it, like right now, AI surpasses the artists and art students?
Well, I'm not sure what would, in purely musical terms, what would surpassing mean? Like, does it mean that you wrote, a more Beethoven type of song that Beethoven would ever write?
Not exactly. I mean, right, that if AI could develop this music even faster than humans, it doesn't need any artistic inclinations. So with that, it can develop more. So you think that AI could possibly be even matched to humans because it doesn't really need to rely on the hormones to develop this artistic inspiration for it?
Yeah, I mean, we're probably getting closer to like AI generative models that take in like a text prompt as input, so you can just formulate what would you like to hear using natural language. But then like the emotional quality, I guess it's going to be different for each genre of music. Like some genres are kind of easier to create with AI, for example, let's take like some background or ambient music, right? Which is just like a couple of chords or like a simple and then lots of reverb, right? And like a nice sounding synthesizer. But I think that that's much simpler for a neural network to grasp than, let's say, like the richness of like, like an opera or like a symphony where there's multiple instruments and like it's a whole piece, so the context is very long. So yeah, I don't know what's the length that ChatGPT can go right now, without losing the plot. But I guess that like in terms of music, like a symphony would be this massive long piece of music with lots of context. And I don't know, we just have to wait, for the ChatGPT of music, I guess.
Thank you. I'll start by saying that since you've given us quite a long list of different clusterization tools and decomposition and other models, I'll be perfectly happy if when answering this question, you'll tell me I should just read the link that's up there. But I thought I'll ask anyway. Can you suggest a good, effective algorithm or perhaps a pre-trained model included with Izmir or other sets of tools for tagging music according to instruments? I have an actual practical use case for this. I have a massive NAS setting sitting with MP3s, which I like and have ripped out of various sources. And all I know about them is that I like all of them. I have literally no information on how else they're correlated, except the hint from a friend musician that most of them seem to feature Roland 303 in some way. And that's the only information I know, and I want more. If I do, can you suggest any specific tools I should look into?
So for like instrument recognition, any of the tagging models will work, because what tagging models work with is like a generalization of like a classification task. So you're not only classifying in one space, for instance, like emotions or like instruments or I don't know, whatever. You're just learning from, you can just learn multiple labels at a time. So if you can do that, then all of those models work perfectly well if you're just trying to recognize instruments. So you can start off with almost any convolutional architecture, and it's probably going to work pretty well for that task. And also there are some data sets that are a good starting point for instrument recognition. There's certainly one that's called IRMAS, IRMAS. And that's like a good starting point as well. So I just go convolutional with those. Yep.
Great. Thank you very much.
Also, awesome. Thank you.
And this will be the last question. Here you go.
Yeah, so hi. I just wanted to ask one question. Did you use any of these models in production, on concerts, or to get inspired with any of your bands? So yeah, did you use programming in such ways that you use it for creative stuff, for real life, on concerts?
Yeah. So some time ago, if you recall, the Michał Milczarek trio, the first band, I showed the posters. So along with Michał, the guitar player from that band, actually some time ago, a couple of months ago, we did this mini EP type of thing that's now on SoundCloud. It has a staggering amount of I don't know, 70 or 100 listens. So it's, a really small thing. But what we used there is a generative adversarial network that was spitting out MIDI. So we didn't edit the MIDI in any way. We just took the MIDI and used different synthesizers and effects, etc., etc. But the notes, their order, etc., what you're hearing, is just totally generated by the neural network. And I hope that these models will become more controllable, so they will be more useful, because sometimes it's hard to have the control that you would have working otherwise. But yeah, we've already released this mini EP. It's on the internet. It's called Drop. and maybe I'll add the link to that repo.
Thanks. Thank you.
Thank you.
Okay. Thank you once again, Mateusz.
Awesome. Thank you.